rest assured. This will be the 6th time we have
covered Voron Phoenix,
and we have become exceedingly efficient at it.
So the Voron Phoenix, it's been a while. It's been a labor of love, a labor of passion.
Yeah, let's go with that.
It has been a lot of labor because this is what, the 3rd potential, hey, we're nearly done type video.
This close.
We're this close. Actually, apparently the way to make it work is to have 14 motors, right?
Yes.
Okay, so we have 14 motors. Max is going to explain what the heck is going on, but it is almost done. This time it's actually almost done.
Mechanically, it is done.
Mechanically, it's done.
Finalized. The bomb is finalized.
The heat expansion issue's been solved.
Correct.
Okay, and we're not using NEMA 723s anymore.
Nope. And the filament feed issues have been resolved as well.
So we've solved the problems.
Yes.
And Max is going to explain because there's a reason this thing has 14 stepper motors now. So take it away, Max.
Since the last show, the Gantry has been completely redesigned. It's mostly 3D printed at this point. We've had to make some allowances for flexible things. The Gantry is actually mounted on TPU now instead of IGOS joints. Basically, the Gantry is soft mounted using 90D hardness TPU.
And then again, so we have its index Core XY.
Yep.
But unlike a normal Core XY, we have 6 motors for our XY motion system.
Correct. So we have basically a quad drive system plus 2 motors in the back for the IDEX to get your hybrid Core XY. Now you could just have one tool head. At that point, you basically just have a quad drive system with a Y assist.
Okay.
Which you can actually do now in stock Clipper.
Oh, nice. So we have an IDEX system, still 600 millimeter cube print volume.
Correct.
And then also, these are all NEMA 17s now. We've dropped
Yes. So the problem with NEMA 23s, especially the 1.8 degree ones, they're just not, they're a little bit of a tractor motor.
They can't react fast enough?
Yes. Yes. That combined with some of the issues with drive electronics, we just weren't getting the results we wanted. So going back to basics and going NEMA 17s and like a normal 2209 drivers has basically resolved most of the issues. The last problem was the filament feed. We had like flagpoles here and they were introducing their own little vibration issues. So all of that is gone and that's what we're doing now.
So now we have the drag chains coming up for the Z, wires and Bowden comes out around.
Yeah, and Bowden and the Bowden cable. Yeah. The Bowden cable and the umbilical for the tool head boards basically travel on the same thing.
Okay. And the tool heads are pretty much the same. These ones have the Luke Slab chibi tubes in them, so we got some nice
chibi tubes,
high flow. And now one of the bigger issues we had on the older iterations of this was heat expansion issues.
Yes.
So everything would expand when you heat it up and push on the bearings.
Yes.
How did we solve that?
So first of all, soft mount the Gantry, so it gets a little bit of flexure. All the parts are 3D printed basically, aside from like small parts here. And then we have slots connecting here. So basically the Gantry can actually fix itself or basically find its own new true self.
So originally it was aluminum machine parts and basically as it expanded it had nowhere to go.
Correct.
And now you just kind of, it's still a rigid.
I gave it somewhere to go.
It's still a rigid system, but there's enough, not slop in the system, but there's enough expansion possible in the system to just kind of handle it.
I gave it some tolerances.
Tolerances, that's the one we're looking for.
And then also the tool head, now this tool head basically homes to this tool head because if you move it here and here, your nozzle offset is whatever is the thermal expansion of this beam.
Oh, that's right. Yeah, as it would expand, your offsets would drift.
Yep. And then, that was not fun.
So now that one homes off that, and then that one homes off that.
Yep.
So expansion shouldn't affect offsets
We're
anymore.
just minimizing the offset.
Awesome.
So now you set it once and then just don't worry about it.
Originally, we reached out to Big Tree Tech. We had the Kraken.
Right.
So that was a control board designed basically specifically for this printer.
Correct.
And
unfortunately, but it was more of a CNC board.
More of a CNC board. So what are we using now? Because we got 10 motors.
Yes.
6 XY, 4 Z.
Yep.
So what are we using to power that?
Octopus 10 Max.
So now we have the Octopus.
This board is kind of insane. It's literally the only board that supports 10 drivers.
So now you could also do.
Argobled is optional.
Argobled is optional.
This is what Amazon had in stock at the time.
Okay.
But yeah, we needed 10 drivers basically to support all of our Gantry stuff.
And of course, you could also split it across 2 controller boards if you really wanted to.
You can, yes. You start running into packaging space.
That is true, because then you would also need, because we have the 10 drivers on there, but then we also have 2 boosters.
Yep.
Which each one of those is using a tool head board.
Yep.
And those are CAN bus.
Yes.
And then we also have the hot ends, which each also have 2 extruders.
Yeah, that's how you get the 14 motors.
Yeah.
10 motors on the main controller board, and then you have 2 and 2 on separate tool head boards.
And that's all CAN bus. And then we somehow 4 USB ports.
Oh,
I'm
yeah.
we're gonna be running. We're gonna need
the 2 CAN.
the 2 CAN. So this is a CAN board hat for Raspberry Pi.
Yep.
So everything plugs right into there to handle all the
It's actually a
CAN.
really nice board. Provides cooling. You get 24-volt supply, which supplies the Raspberry Pi with power. You get 3 extra USB drives, and then you have 2 CAN bus, because that's where 2 CAN comes from.
Oh,
it's
nice.
clever.
Nice. And it's still a pretty clean package.
Very,
So-
very. And Steve does.
Yeah,
Phenomenal
this machine
wiring.
here is Steve's. So.
Yeah. This is why you know it's Steve's. It's not a complete mess.
And then we do have these slots in the back here, so that's where the filament goes in.
Yep.
And then these are chamber thermistors, I'm assuming?
Yes.
Okay. That is really clean there. So, you said soon. So this is now mechanically complete. You are happy with the motion system, with
Yes.
the way it operates, with the way it prints.
The next thing is the manual, and it's probably going to take us about a year. So sometime this year, it's going to come out.
Sometime, for sure, we're going to hold you to it?
Yep.
Okay. Because I know a lot of people have been interested in this, and it's just one of those things that you get it to a point where it kind of works, but you're not happy.
And then you
start-
find something else.
Yeah. And
But
big printers are big problems.
yeah, and it's working now.
Yeah.
And all the big printer manufacturers are finding out the same problems that we found out.
Like, again, I just built a Venture XL.
Yeah.
And for those that don't know, the Venture XL is essentially a big V2. So it's a 600 millimeter V2. And I'm running into the thermal expansion issues. I enclose the printer, everything expands, and now my rails are grinding.
Weird.
So it's a universal thing. It's not hard to build a big printer.
No.
It's surprisingly easy to build a big printer. It's hard to build a big printer that's good. And that's the problem. So if you are building a big printer and you're looking for ideas, there you go. Because this has been how many years now? 3 years?
Since this project started, 2.5.
2.5?
Almost
Yeah.
3.
So it is what it is, but
It is.
it's almost there now.
It is a thing.
It is a thing. Soon to be a thing.
Yes, for sure.
So there you go. There's your annual update on the Voron Phoenix. And soon.
Hopefully
Hopefully
we
soon.
will stop the annual updates on the Voron Phoenix. And
Hopefully next year
can
it'll
just
be like
release it.
next year it'll be done. It'll be done.
it's done. Here's the manual.
We won't have to do this next
Please
year.
stop asking me those questions.
Trident will be soon. Trident
Yes.
R2 will be soon.
Actually soon.
Yeah, that one will be soon.
Not
In fact,
Voron soon.
Go watch the video.
Actually soon.
I'll link it below. Go watch the video on the Trident. Link below. Anyways, cheers, Max.
Dude, always pleasure.